Hi class. In this next example, what I want to do is I want to walk you through a problem of a double integral in which you need to switch the order of integration. All right, let me talk about it and set this up. So I have this double integral from 0 to 3, then from x squared to 9 of x cubed e to the y cubed dy dx. I suppose you just see this integral and you're like, oh, okay, let me just jump in and try to integrate it. When you go to do the dy integration here, x cubed is constant, but how do you integrate e to the y cubed? Like if it was e to the y, it would be easy, e to the 2y, but e to the y cubed here makes this hard. Like there's nothing here, there's no trick right now that I can use to integrate this. So it's like, shoot. I might want to take this now and change it from a dy dx to a dx dy. All right, to figure out how to do that, one thing that helps is to set up the region. As you can see over here, I have the region sketched. Okay, so the dx is telling me it's going from 0 to 3 here. And then my y variables, okay, are going to start at x squared, so from 0 to 3, okay? And then it's going to stop at y is equal to 9. And you can see right there is the red line, y is equal to 9. So when I switch this to dx dy, okay, what I need to do is my integration, my bounds of integration here, I need to solve this stuff in terms of x. So this is what I was doing. In this problem, let me go back. In this problem here, I was doing the integration by doing vertical rectangles. By switching it here to dx dy, I'm going to start with horizontal rectangles first. So how does my x values vary horizontally? Well, it looks like it starts at 0, and then I'm going to take this y is equal to x squared and solve it for x, and I get x is equal to the square root of y. So my x values are bounded by 0 and stopped at the square root of y. Okay? Now where do my y values range from, my dy? Well, y starts at 0 and goes to 9. So that's how this bound here changes from 0 to 9. Now once you have this double integral is trivial to solve. So you're going to integrate the x cubed first. Well, that integrates as 1/4 x to the 4th power. Now you're going to plug in y, the square root of y for x. So the square root of y to the 4th power becomes y squared. Plugging in 0, it wipes it out. So you're just left with this. Now how would you solve this? Well, now you would just substitute this to solve. You would let u equal y to the 3rd, and then solve from there. Du is equal to 1/3 y squared dx, and you got it. So this simply would then integrate as 1/12, because the 1/3 times the 1/4 would get me 1/12 e to the y cubed. And then you're just going to plug in using your fundamental theorem the bounds of integration 0 to 9. And 9 to the 3rd power is 729. E to the 0 power is 1. And I just factored out the 1/12 here. So here you have this hard integral. Sometimes when you see these problems, if you have these hard integrals like this, like, I don't know how to tackle it, try initially switching the order of integration. And then a lot of times you'll see, oh, okay, this becomes a much more manageable integral to solve, double integral to solve.